Through OPTEX-GPT, HYPOTHALAMUS Artificial Intelligence will be your advisor for the best decision-making. The future is now. OPTEX Optimization Expert System is a new vision of mathematical programming. OPTEX Optimization Expert System is a generative artificial intelligence focused on the design, implementation, startup, and maintenance of high-complexity mathematical programming models. OPTEX was created by Decisionware Limited, DW, in 1990, and it can be considered the father of the artificial business brains produced by HI, a DW spin-off company. The way the mathematical modeler communicates with OPTEX is through a standardized database, a unique data model for all mathematical problems or subproblems. It also allows you to perform high-level operations between models, such as joining or splitting them, and implementing multi-problem solutions, according to large-scale optimization technologies, or using multi-problem procedures, such as constructing optimal numerical functions. This allows the modeler to build mathematical frameworks in the same way that Lego models are built. A mathematical model stored in an information system can be conceived as the union of mathematical components harmoniously integrated. There are two types of components, or objects: basic mathematical definitions, indexes, sets, parameters, and equations or constraints; advanced concepts, problems, models, decision support systems, and artificial hypothalamuses. These components can be stored in a relational information system. It permits their handling in a modular way. Following the principles of relational information systems, and use structured query language, SQL, to manipulate the mathematical objects. This conceptualization is independent of optimization technologies, which allows to separate the formulation of the mathematical models from their implementation, using a specific optimization technology. The definition of the models is done by filling in the blanks of the tables of the expert system, which can be done in multiple ways. One of them, standardized tables filled in Word or Excel. Joining, or splitting models, is done by keeping records in tables. The diagram on the right shows the structure of a decision support system, or an artificial brain, to support companies in the electricity sector. Structured modeling allows OPTEX to consistently handle tens, hundreds, thousands, and generally any number of models and all of their components. These models share components such as constraints, variables, etc. The algorithms are generated by OPTEX, following the user's instructions, which can take multiple forms, such as a timer, or triggering the algorithm from another algorithm, or manually in any window. OPTEX automatically provides a hologram of the standard user interface, which is generated inline as the user explores the system. OPTEX's standardization, while limiting the modeler in the creative development of their programs, allows OPTEX to be the artificial intelligence, generating all the programming components necessary to implement an artificial brain, which is the new artificial intelligence, which replaces the decision-making support systems of the past. To do this, OPTEX generate the artificial hypothalamus algorithm, which is based on a mathematical language between robots, based on the theory of duality, and which allows to solve multiple problems, under a scheme that we can call autonomous real-time distributed optimization, similar to how the human hypothalamus operates. Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. OPTEX can produce infinite lines of perfect source code per period. OPTEX generate artificial brains, or DSS, in many technological platforms, like IBM Alog, GAMS, AMPL, Mosel, AIMS, C, and Python. OPTEX connects with the most advanced optimization algorithms like Gurobi, Cplex and Express. The artificial brains is the evolution of DSS under the Industry 4.0 revolution that is conceptualized as a set of mathematical models that exchange autonomously information between them, working online, using distributed optimization. The OPTEX Expert Optimization System is based on an artificial hippocampus, which stores structures and processes for scientific decision-making that must be permanently consulted. Artificial Hippocampus store, like in the humans, the experience, and the knowledge acquired over time. Mathematical Modeling Expert Systems. A knowledge-based system, KBS, must store two types of knowledge: mathematical components, equations, problems, models, previously used and working properly. This information is generated by the modeler who builds the mathematical models and their entire operating environment, and results of previous runs to speed up the solution of new problems. This information is generated by the math models when they are used, and correspond to the trajectories of the variables involved in these models. The use of this information is totally dynamic, since it depends on the value of the input parameters in each new run. OPTEX was built as a high-level artificial intelligence that makes artificial intelligences. That is, robots making robots, that make robots like OPTEX, from whom they inherit their characteristics. OPTEX, Research and Development plus Innovation. The R&D plus Innovation projects carried out by HYPOTHALAMUS Artificial Intelligence are neural nets applied to warm start using large OPTEX Artificial Hippocampus. OPTEX-GPT, an artificial intelligence front-end for OPTEX. And OPTEX and digital twins. The first two focus on the incorporation of artificial intelligence in the management of the artificial hippocampus, and the AI end-user interface. The third is to upgrade OPTEX's visualization capabilities by linking them with digital twin platforms. Generative Pre-trained Transformers, GPT, are a family of neural network models that uses the transformer architecture, and is a key advancement in artificial intelligence, powering generative AI applications such as ChatGPT. GPT models give applications the ability to create human-like text and content, images, music, and more, and answer questions conversationally. Organizations across industries are using GPT models and generative AI for conda, text digesting, content generation, and search bots. Source: aws.amazon.com. Following the principles of generative pre-trained transformer AI, OPTEX-GPT will be the advisor that helps mathematical modelers and professional users when they require solutions in line with today's cutting-edge technology. OPTEX is focused on the implementation of artificial brains, conceived as a union of optimization models with information systems. In the development and maintenance of high-complexity mathematical programming, OPTEX avoids the intensive use of resources for programming computers. A large language model, LLM, is a statistical language model, trained on a large amount of data, that can be used to generate and translate text, and other content, as well as perform other natural language processing, NLP, tasks. LLM has existed since 1990 within the field of computational linguistics, which is a subdiscipline of artificial intelligence. The basic statistical model of language consists of probabilistically predicting the word that follows a chain of previous words. In this way we can construct a sentence as a set of words, construct a paragraph as a group of sentences, and from groups of paragraphs construct a chapter, and so on. Like any statistical model, its parameters must be estimated. Since 2000 the LLMs are done using specialized artificial neural networks, recurrent networks and long short-term memory, LSTM, nets. In 2017, GPT networks emerged, increasing the long-term memory, the number of words that can be used to predict the next word. Additionally, GPT networks can analyze context, since they can handle models with relationships between words, phrases, paragraphs, other levels of word grouping. In 2018, Google launched BERT, the first GPT network with practical applications. Like any statistical model, accuracy depends on the sample, quality and size, and the number of parameters used. Currently, LLMs can estimate billions of parameters. This is due to the power of today's computer science. The essence of the project is focused on uniting the OPTEX database with an artificial intelligence, built following the methodologies of the GPT artificial neural networks. Starting from a real-world problem. For implementing complex mathematical models from MS Word, the stages are: First, convert the algebraic model to a formulation in MS Word, in the form of tables. Second, convert MS Word tables into CSV files in standardized ANSI format. This may require an intermediate step that goes through MS Excel tables. Third, upload the CSV files to the OPTEX database. This process is carried out with the support of OPTEX, which automatically validates that the mathematical elements are correctly formulated. Fourth, generation of the source program of the mathematical model on the selected computational platform. The second step may be shortened, loading the information from MS Word directly to OPTEX, using the MS Windows clipboard. The process of uploading OPTEX will be a more interactive activity through generative artificial intelligence, such as ChatGPT Omnichannel 4.0. In this way, the user will be able to communicate with the OPTEX model database, and use all the documents produced by HI for the management of the system. All through a conversation, out loud if you will, with OPTEX-GPT. At the limit, if the user wishes, OPTEX-GPT can perform the entire process in a single step, until the results are delivered. There is no need to store intermediate results. The basis of the OPTEX-GPT conversation will be based on so-called prompting engineering, called by HI as the engineering of ideas. OPTEX-GPT will be a specialized generative artificial intelligence to work in the OPTEX optimization expert system environment, which will be powered by mathematical models that exist in the current OPTEX database, and of all new models, and/or the algebraic components, that will be introduced. Another source of information, commonly used to produce mathematical models, are publications, free of charge or acquired from publishers, which must be consulted by mathematical modelers, and from there, adapt the models they are going to implement. The idea is that OPTEX-GPT can help in this process of normalization of unstructured information sources to information structures in MES. From the correct configuration of the MES, the modeler will be able to configure the required algorithms, link them together, and generate the computational code of their choice. Finally, she will be ready to run the multi-problem models. An evolved OPTEX-GPT could help experts in field problems, but not experts in mathematical modeling, to generate advanced, ready-to-run mathematical models. The data source for building a model can be the description of the real model, and/or the algebraic formulation, and/or pre-existing models in the OPTEX database. Another of the functions of OPTEX-GPT will be aimed at supporting users in specific applications, to accompany them in the process of elaboration, or selection, of mathematical models, the loading of industrial databases, and the interpretation of the results. The main product is the management of IDIS, Industrial Data Information System. This work will be advised by OPTEX-GPT, based on the data model of the IDIS database. This includes the verification of the validity of the database, considering the metadata of each of the fields of the tables. As an advisor, OPTEX-GPT will have access to a database of documents, some generic and some specific, to facilitate the understanding of the company-wide optimization system by the user group. Thank you for your attention.